Hey there! Today we're diving into the fascinating story of the F-22 aircraft, a true engineering marvel that deserves more recognition in aviation history. Let's get started. In a competition between giants, there's always a party that loses out. Such is the story of Northrop Corporation's F-22 aircraft, of which only 2 prototypes were made, lovingly known as the Black Widow II and Grey Ghost. Today, most people have forgotten about this phenomenal aircraft, and even those who remember it have placed it as a footnote of history, as the aircraft that lost out to the mighty Lockheed Martin's F-22, now known as the F-22 Raptor. However, the aircraft that Northrop Corporation produced was anything but forgettable. Let's delve into the past and uncover why the F-23 was a masterpiece of modern engineering. 40 years ago, the chances of a nuclear war were quite possible, with 2 superpowers involved in an invisible war. It was felt that the United States would find themselves in a terrible shooting war against an extremely heavily armed Soviet Union, with a 4-to-1 military advantage belonging to Soviet forces in Eastern Europe. Those were legitimate concerns not only for the United States, but also their political allies in Europe. At the time, the United States and its allies were heavily dependent on the F-15 Eagle aircraft. Although a brilliant aircraft in many regards, it was getting old and had a very slim advantage against the new Soviet aircraft like the MiG-29S and the highly modernized aircraft in the Su-27 family. It was enough for the United States Air Force to realize the need for a new fighter. Thus, it took a bold step in the early 1980s to come up with the new requirements of a new air superiority fighter under a program called the Advanced Tactical Fighter (ATF) program. From the initial requirement stages, the main focus of the US Air Force was on a few features that the new aircraft would absolutely need to have. It included all-aspect stealth, meaning the ability to have a reduced radar cross-section over various flight regimes. The engine should be able to supercruise, which is flying at supersonic speeds without the use of an afterburner. The use of composite materials and new alloys in construction processes to reduce the overall weight of the aircraft. Advanced fly-by-wire systems to make the aircraft more maneuverable. And finally, the aircraft should have short takeoff and landing, STOL capabilities. After the initial years of evaluating proposals and designs, the prototyping and flight testing contract was awarded to Lockheed Martin's F-22 design and Northrop Corporation's F-23 design in 1986. Northrop Corporation has always had a history of building high-performance aircraft. Its founder, Jack Northrop, was the first aviation designer to pioneer the flying wing concept, which led to the eventual development of the B-2 stealth bomber, currently the primary long-range stealth bomber of the United States Air Force. Following the same legacy, the designers at Northrop partnered with McDonnell Douglas to design the F-23, which many still consider to be more technologically advanced than its competitor. The F-23 prototypes were 67 feet 5 inches in length and had a wingspan of 43 feet 7 inches, slightly bigger than its competitor, the F-22, giving it a slight advantage in range and speed. The prototype air vehicles, PAV-1 and PAV-2, were powered by 2 Pratt & Whitney YF-119 and 2 General Electric YF-120 afterburning turbofan engines, respectively. Both engine types were able to meet the minimum ATF program requirements, generating 40,000 pounds of thrust with afterburner and the ability to supercruise. However, in the end, the Pratt & Whitney YF-119 was chosen to power the winning entry of Lockheed's F-22. Both prototypes could reach a maximum speed of Mach 2.2 and supercruise at Mach 1.6. The F-23's wing design was brilliant, featuring diamond-shaped wings or trapezoidal wings, which allowed the designers to reduce aerodynamic drag at transonic speeds between Mach 0.75 and Mach 1.2. This meant that the aircraft had good low-speed performance despite being an overall fast jet. The trapezoidal wing setup also offered advantages for high-speed flight, with substantially lower drag at supersonic speeds than other configurations. The wing's tapered layout also reduced structural stresses, allowing it to be made thin, using less material during construction and keeping the overall weight of the aircraft low. The F-23 also featured an all-moving V-tail in favor of the more traditional vertical fins and horizontal surfaces, a configuration known as a butterfly tail. This unconventional design reduced the overall exposed surface area of the tail, leading to less parasitic drag and making the rudder controls more effective for maintaining proper yaw control during high-speed flight. The cockpit of the YF-23 was placed very near to the nose of the aircraft to improve overall pilot visibility. The aircraft had a conventional tricycle undercarriage layout with the internal weapons bay placed on the underside of the fuselage between the nose and the main landing gears. This meant that the aircraft would carry all its weapons inside, not on wing hardpoints, to maintain its stealth characteristics. The YF-23 prototypes were powered by two different engine manufacturers, Pratt & Whitney's YF-119 and General Electric's YF-120, which were in their competition to produce the best-in-class Super Cruise-capable engine. Both engines produced approximately 70,000 pounds of thrust combined, a significant increase in engine performance compared to the F-15 Eagle, whose two Pratt & Whitney F-100 engines could only produce around 40,000 pounds of thrust in the afterburner setting. This increase in engine performance marked a major technological breakthrough for the ATF program, leading to the creation of the first supercruising jet fighters globally. One of the major challenges for ATF program designers was to provide stable airflow to high-performance engines on an airframe that was hard to spot on radar. The issue had to do with airflow boundary layer, where air around the aircraft's fuselage could flow at different velocities and directions compared to the air that's offset from the aircraft's surface. Mixing these two streams of air could lead to large drops in engine efficiency during certain regimes of flight, especially at supersonic speeds. To address this issue, the YF-23 featured an innovative solution called the Boundary Layer Control System. This system involved gauzing panels ahead of where the fuselage met the leading edge of the air inlet, which sucked up the boundary layer air and vented it out through small doors on the YF-23's upper surface, maintaining a steady stream of air to the engine compressors even at supersonic speeds. The YF-23's armament system was based mainly around air-to-air missiles and air-to-ground bombs. Since all weapons had to be carried inside the internal weapons bay to maintain stealth, the overall payload capacity was not as extensive compared to other conventional fighters. However, the YF-23 could carry the standard AIM-9 Sidewinder for close air-to-air fire, and also the AIM-120 AMRAAM or the AIM-7 Sparrow for medium to beyond visual range targets. The aircraft also featured an M61 Vulcan cannon, which could fire 20mm rounds at a very high rate of fire, around 6,000 rounds per minute. It had the capability to carry up to two 1,000-pound or four 500-pound air-to-ground bombs. After 4 grueling years of testing and evaluations, the YF-22 was selected as the winner over the YF-23, a decision that remains a subject of debate among aviation enthusiasts. The designers of the two YF-23 prototypes have always remained firm in their belief that their aircraft was superior and more technologically advanced. However, various political forces and lobbying swayed the decision in favor of Lockheed's YF-22, which is still currently in service as the F-22 Raptor. On the other hand, the two YF-23 prototypes, PAV-1 and PAV-2, were donated to air museums and are never to be flown again. In recent years, there's been a glimmer of hope for the revival of the YF-23 in the form of Japan's F-3 sixth-generation fighter. Japan is seeking the help of Northrop Grumman in aiding their design and development of its F-3 fighter program. Given the entire experience gained during the development of the YF-23, the company is optimistic about securing the contract for this project. Regardless of what the future holds, aviation enthusiasts would love to see the return of the YF-23 in its reincarnated form, taking to the skies and bearing fruit to all the research and hard work that was spent in making this magnificent aircraft that everyone seems to have forgotten. And that's a wrap on our journey into the world of the YF-23 aircraft. It's a story of innovation, competition, and the pursuit of excellence in aviation. If you enjoyed this adventure through history, stay tuned for more exciting explorations. Don't forget to like, subscribe, and hit that notification bell to join us on our next thrilling ride through knowledge. Until then, keep soaring high, and we'll catch you in the next chapter of discovery.